Integrated Math 3, this is lesson 1.04, z-squares. This is the last lesson in our statistics unit. So what is a z-score? A z-score measures how many standard deviations a data value is from the mean. A z-score is also known as a standard score, although we never call it that in this class. And a z-score ranges, at least in this class, what we're gonna do ranges from -3 standard deviations to +3 standard deviations. Okay, so this is a normal distribution, and the percentages have been adjusted to make the calculations easier. To further simplify, 100% of the data values will fall between plus and minus 3 standard deviations of the mean. So you remember there was that little 0.13 that was to the right and 0.13 to the left, but they've just adjusted the numbers here so that if you add those percentages up, they add up to 100%, and all of them are within one of the 3 different standard deviations, 1, 2, or 3 standard deviations from the mean. So z-score is calculated with the following formula. So the z-score equals x minus mu divided by sigma. So mu is the mean, sigma is the standard deviation, and x is the data value that you're interested in determining the z-score for. The best way to learn this is through examples. So let's go ahead and do that. So there's the formula. We'll keep that up on the screen. So the lifetime of a battery is normally distributed with a mean life of 40 hours and a standard deviation of 1.5 hours. So what are the chances that my battery will die in less than 37 hours? The first thing to do is go through this normal distribution and put down the specific number of hours that 1, 2, and 3 standard deviations would be. So if you take 40 and add 1.5 to it, that's 1 standard deviation to the right. That would be 41.5. If you add 2 standard deviations, that would be 43. And if you were going to add a third one, it's shown on this diagram, but if you were to add a third one, it would be 44.5. You just add 1.5 each time for an additional standard deviation. In the other direction, it's 40 minus 1.5, that would be 38.5, and 40 minus 1.5 minus 1.5 again would be 2 standard deviations below the mean, and that would be 37. Okay, so then the question, going back to the question again, what are the chances that my battery will die in less than 37 hours? So you can see that 37 hours is labeled over there between the blue and the green region. And so the chances, in other words, what percentage is really what they're asking for, is going to be that 2.5% green area on the left. Remember, we're dealing with a situation where there's nothing beyond the 3rd standard deviation, so 2.5. If you wanted it as a ratio, it would be 2.5 over 100, and that would be 1 out of 40. There's a 1 out of 40 chance if you wanted to express it that way. We'll get in at a later time how to deal with percentages, convert them to different things, to ratios and ratios to percentages. We'll do that at a later time. But for right now, that's how you could just say 2.5%. Okay, so what are the chances that my battery will die in less than 37 hours? Well, I just told you. There it is. 2.5%. So everything to the left of that intersection between the blue and the green. How many batteries would you need to buy if you wanted to be sure that 27 batteries will be good for 40 hours? So the answer to that is the median is 40. So so median is the same as the mean and the mode in a perfect normal distribution. So half the batteries will last more than 40 hours, and half the batteries will last less than 40 hours. That's what a median means. It's the number that's right in the middle of all of the numbers. This means that a sample must be 54 batteries so that 27 will be above 40 hours and 27 will be below 40 hours. So if you want to be sure that 27 will last at least 40 hours, you need twice that many, because half of them will last 40 hours or more, but half of them won't last 40 hours. So the answer is 54 is the number of total batteries that you would need. Okay, here's a different question. 3 students take equivalent stress tests. Which is the highest relative score? So what does relative score mean? It means in relation to how many questions they had. If one student took a quiz with 10 questions and got 9 of them right, and another student took a test with 100 questions and got 60 of them right, well, certainly the second student got more answers right, but that's because that student had more questions to attempt. So, but if you wanted to look at basically the percentage or the ratio that they got right, the one that took the smaller test, the 10, actually did better, but just based on percentage or relative score. That's what relative score means. So here's the first one, a score of 144 with a mean of 128 and a standard deviation of 34. So this is pretty simple. You just plug the numbers into that equation. Here's the second one, a score of 90 with a mean of 96 and a standard deviation of 18. And finally, a score of 18 with a mean of 15 and a standard deviation of 5. So we'll just take them one at a time and figure out the z-score for each of those. Okay, so 3 students take equivalent stress tests. So here's the first one, a score of 144 with a mean of 128, standard deviation of 34. You just plug in the numbers and do the math on a calculator, and you get 0.47 standard deviations above the mean. So that first student was 0.47 standard deviations above the mean. That's the number you want to look at when determining who had the highest relative score. Okay, and here's the second one, score of 90 with a mean of 96 and a standard deviation of 18. So you do the math on that, and you actually get a negative number for standard deviation. So that student fell below the average score, below the mean score. So 0.33, negative 0.33. So they're below the standard deviation. So they definitely didn't get the better than the first student. Okay, and then the last one, a score of 18 with a mean of 15 and a standard deviation of 5. So you do the math on that, and you get 0.6 standard deviations above the mean. So now to compare the 3, you have them side by side, and so the student with the highest relative score was C. 0.6 standard deviations above the mean is higher than 0.47, so that student had a higher relative score. Okay, so that takes care of it. That was our simple little lesson on z-scores, and it's just about interpreting standard deviations and means. That's all the statistics you're going to get in this class. You'll get a more serious treatment of the subject if you actually take statistics, and there is even AP statistics at Hoover, and it's a pretty valuable type of math to learn if you're going to do anything involved in mathematics. So that's it. We'll see you for prep lesson for the exam for this unit, and it shouldn't be a real hard test, and we'll get you ready for it, and we'll take that coming up soon. Have a good day.